You're good now.
Hello. Yeah. Thank you, Jimmy, and thank you, Josh. I think Kubeflow 1.4 would help us, overcome a lot of the logistic issues while using Kubeflow, and especially on installation, right? Starting with this, I am Joinal. I work as a data scientist at Halodoc. Here today, what I'll cover is, what are the various issues with pushing a model into production, and also the overall ML life cycle, and also like there are some of my personal views that I have seen and experienced, and also how we can then solve that using or adopting Kubeflow. Yeah, so engineering like efforts into enabling ML is a lot, right? Developing the model is one bit of part, and the issues that are there along or in the ecosystem is not actually on the machine learning, but the tooling that we around it. It can be infrastructure, it can be data engineering related issues, it can be monitoring, dashboarding, and a lot of those kind of issues. And these work that goes together while deploying a machine learning solution into production is actually what taking a lot of time. Maybe what I have seen is, the data science team can develop a solution within months, but then it takes double the amount just to make sure that it gets deployed, because it needs to get integrated with the overall product. We need to take care of how do we deploy this, how do we make sure that it auto scales, and all of those issues. And that is where the whole ML technical depth concept comes in. Here I'm just showing a typical view of how a machine learning project life cycle, starting from sourcing the data to the next step we do is exploratory data analysis, data transformation. Then once we and there are certain scheduling automation job required to maybe load the data, retrain the models, train the models, and everything. Then once we have a model trained, then the next part of things comes into how do we manage and deploy the models, serving and monitoring, and at the last, right, since model can go stale very fast, how do we retrain and make sure that our models are fresh at production, and the predictions are always relevant. Yeah. So typically how a data scientist performs, right? A data scientist develop the model in siloed notebooks, maybe running on the local machine, maybe some cloud, Jupyter Hub installation, and where they basically develop the models. And also the data scientists train these models on files, databases, which are also very staggered, and it can be in S3 buckets, that could be in on-premise storage, and all over, right? Once the models are there, then a backend engineer comes into the picture, where they then work with the data scientists to put the model into deployment as an infinite service. Along with that, while these two guys are trying to put the model into production, there comes a DevOps engineer, there comes a security engineer who takes care of the other parts of the work. And while they are working together, this takes a lot of time even to understand and push the model into production. And this also has repeated work that needs to be done every time they do together. Yeah, so there are several problems. One is no standard ML life cycle, and this leads to hidden innovation and duplicated efforts, right? As I said, right, maybe for one project we are writing an Airflow DAG that migrates the data from one source to destination. Then for every project we need to do that. We need to write the DAG, we need to provision the infrastructure and everything. Same with how do we same with when we push a model into production, right? The same kind of things needs to be repeated, and also the infrastructure related issues that need to be solved every time there is a project that needs to be pushed forward, and which leads to a lot of duplicated effort. Second is, yes, challenging the data science team into production is the engineering effort that is required, because as a data scientist, these are not primary skills of a data scientist, where they take care of how the project, how the model needs to be integrated, how it is need to be auto scale, and all of these issues, right? And that is where the second problems comes in. Third thing, in again, monitoring these models into production is another issue. How do you make sure that models are always fresh, and the predictions are the models are making always make sense to the user. And because user behavior change, there are a lot of implicit and explicit feedback loops that can influence the model's performance over time. Then how do you solve these issues? Also, a lot of time, these data science models are developed as a POC, or just can we do this, right? Can we solve certain issues? For our example, at Halodoc, we figured out, okay, can we predict the context of the consultation that happened, and if we can do, we can then also solve a lot of downstream healthcare issues. Yeah, so talking about these problems, now let's look a bit forward and how and what we can do to solve it. So here comes ML ops. ML ops is basically when you merge machine learning development or data scientist to operations, or a ML. Sorry. Yeah. Data scientist with an operations flow, right? So this ML ops platform, I think this should be adopted in the industry very widely, and all of the companies should have it. What it makes sure that all the monitoring, automation, all the infrastructure related work, integration, testing, releasing is already taken care of. So so the people, the data scientists, right, they can do or focus at what they are good at. Right? They can just focus on building the models, building the solutions, and the infrastructure part of it can automatically be taken care of. Yes, and also with Kubeflow, it makes deploying this models very easy with Docker and Kubernetes into the picture. That that makes sure that these solutions can be are portable and can be run anywhere, which with a very less effort. And with the Aricto's MLOps offering that we have, Kale, Rock, it makes even simpler, right? Instead of me writing the whole Kubeflow pipeline, I can just tag my notebook with appropriate text using Kale, and the pipeline can be built automatically, and then it can be deployed, and also the training process can be automated. Yes, so an enterprise MLOps platform, what it should offer, right, or what the goal should be of an MLOps platform. It should create, it should empower the data scientists to drive, direct business impacts and building the models without actually worrying on the infrastructure. This should, provide a unified set of tools, all the tools that are required, right, from a phase where we are just thinking about building a model, the data engineering, how do we get the data to a point where how do we deploy the model. The whole life cycle should be taken care of, and the folks, right, the data scientists should not worry about it. And the whole Kubeflow is designed around Docker and containerization, right? And it runs on Kubernetes, so it makes sure that it can be it's portable enough to run everywhere. Yeah. So a simple, how do then how it looks like using Kubeflow for an end-to-end project, right? Starting from and also these are the best practices that we should always containerize our sample or base images, so that every time we need to do an experiment, we can just pull out an image and start working on that, instead of every time creating a fresh environment, installing on the packages, and then running a Jupyter notebook on top of that. Then once we have our baseline environment containerized, then we can run a Jupyter notebook on top of that and write our codes into a notebook, and then we can convert them into a pipeline where for training the jobs. And once we have a decent enough pipeline ready, then we can go ahead and do a hyperparameter optimization on that. And then once we have a very good model that we are very confident on that it can perform good, we can then go forward and deploy. And once and in deployment, we can then look at how different models are performing with the same set of users, or maybe we can look at the explanatory part of it, that the predictions that the model is making, why it is making that. We can look at the decision points of the model, and maybe using SHAP values, maybe using the other metadata it generates and figure out, okay, why a certain decision has been made. Yeah, so the first is containerizing the ML workflow. This is, should be again always adopted because containerizing the ML workflow makes sure that it can be run anywhere, and the distribution. And let's say I made a job today, and let's say a couple of months later I need to rerun it and make sure, and then it helps me, right? I don't need to make the environment again. I do not need to install everything again. The container is just there. I can just pull it up. Uh, I can just pull the Docker image and start running it. Yeah, it also helps, if I need to run a job periodically, right? Then it also helps that, right, we can make the overall ML workflow faster using containerization. Second is the Jupyter notebooks. Yes, you obviously, right, all the data scientists tend to write all their code into Jupyter notebooks, and using Jupyter notebooks, right, we can basically also make it very presentable to the other folks who are not very much into, like, showing them a ID would be very uh, difficult for them to understand the whole part of the code. But in Jupyter notebooks, we can divide all the segments into different cells, and then from there we can explain to them, right? And with Kubeflow notebooks, which comes inside it, and also with the authentication, access control, infrastructure sorted out, right? It also enables the teams to collaborate together. This like people from the same team can access each other's notebooks and see how they are doing the work, or collaborate to solve issues. Yeah. Yeah. So once these notebooks are ready, and we have tested out our solution, then we can go ahead and write a Kubeflow pipeline. Kubeflow pipeline using all these sections of the notebook. Then we can use Kale to tag all this together. And what Kale then does is basically Dockerize everything and builds the pipeline for us, so that we don't need to write using Kubeflow DSM. And it also helps end-to-end orchestration of the machine learning pipelines. Yeah, so another helpful tool that comes with the Kubeflow is Katib, right? Katib helps into optimizing the models and running hyperparameter tuning on top of that. We can select, okay, I need to run a Bayesian optimization on this. So basically on the top of same Kubeflow pipeline, we can run Katib, and we can log all the metrics that are generated, and then decide, okay, which model works best for us, and go ahead and deploy it. Deployment is again very easy. We can just simply use KF serving on top of that. KF serving again takes care of like Josh mentioned, right, server configuration, networking, auto scaling, hardware issues, and all of these are already taken care of. So we don't need to figure out every time we need to deploy a model. We did not need to go to these issues. We can just decide, okay, a model this need to be deployed. We can just expose it using KF serving, and it also takes care of all the different frameworks that data scientists use, the TensorFlow, PyTorch, XGBoost, scikit-learn, all of them. There are also some of additional features that comes with it. One is one is this is auto scaling the inference service. So in the deployment YAML, we can just enable this flag, the auto scaling on Knative, and once you enable this flag, the Kubernetes cluster takes care of auto scaling automatically. And the next is canary deployment strategy. So there could be times where we are having multiple models. So let's say one version of the model is in production, and I want to release a new version of it. Instead of releasing or transferring all the traffic to the new version, we can just decide on a canary deployment strategy where we are sending let's say only 10% of traffic to the new model, and the rest of traffic to the old model, right? And we monitor the performance, and gradually we can then transfer the whole traffic to the new model, and then retire the old model. And this feature also helps us to run A/B tests on the platform, because Here I can just have multiple models having multiple segments or various segments of your traffic going to various models, and then we can log how these different models are performing, and then decide which versions of the model, or which predictions makes more sense to the user, and which are more efficient. One more thing comes into while into model deployment and ML governance is ML explainability, right? Why the model made certain predictions, and it is also very necessary in certain domains. Let's say in banking, in healthcare, right? Sometimes we need to explain, why the bank decided not to give a loan to the person, right? So we can then look at all the decision points the model make to explain, okay, why a certain decision has been made, right? In our case at healthcare, where we are extracting the disease information from the whole doctor notes, we can see, okay, which part of the whole sentence the model gave more importance, right? Using some visualization on top of it, or using this raw dumps, right? And then this can be used to explain to other stakeholders that why the model is performing in a certain way, why a certain decision has been made. Yeah, so instead of using different tools into building the ML of the platform, here Kubeflow comes very handy, right? Because Kubeflow offers a suite of tools inside it, right from for, like Kubeflow notebooks, or Kubeflow pipelines, KF serving, and all of this, right? So that covers, and also the team doesn't needs to have multiple tools to solve various like specific issues. And if you have multiple tools, then that also makes the person who is managing them life difficult, right? So here there's only one tool, Qflow, and there are a suite of tools that comes inside it, and using that the whole ML of journey can be done. Yeah, so while Kubeflow has this tool, there are certain more offerings from Aricto that helps in the whole ML of journey. One is Kale. So Kale, using Kale, it automates a lot of uh, things, right? From notebook, and using just simple tagging, these pipelines can be made. Like hypermeter jobs can be started. We can also look at the matrix. We can solve, or we can expose the models um, using APIs, like Josh showed, right? We can uh, deploy a TensorFlow dashboard on top of that, which then helps us to explain, or look at how the models is performing, how and every step of it. Uh,